Let's work some elastic collision problems. Remember when I say elastic, think of the word bounce, okay? They do not stick together. Alright, so let's see. Suppose I have two masses, M1 and M2. And say, these are trucks or blocks or cars or whatever. And let's say M1 is moving with a velocity V1 and V2 is moving with some velocity V2. We have a collision. Remember, my double arrow here always means collision. They've hit each other. Without some sort of collision, you don't have our conservation of momentum occurring. So, after the collision, M1 moves off with some velocity after the collision of V1 prime, and M2 moves off with another velocity of V2 prime. Now these directions may be to the right, they may be to the left. When you write your conservation of momentum law, always read it straight down. So this is M1 V1 plus M2 V2. The collision sign is always your equals. M1 V1 prime plus M2 V2 prime. Now if you get your data and you organize it in tables, it turns out you can read these quite easily. Let's do a couple. Suppose I have a 35-gram bullet. Okay, I'm going to stop right there because I want to go and convert this because I know I'm going to need to convert it to kilograms. 35 grams times 1,000 grams is 1 kilogram. So this is 0.035 kilograms. Alright, so I have a 35-gram bullet, so that's M1, moving at 475 meters per second, and it hits a mass 2 of 2.5 kilograms. It's a wooden block. The bullet passes through the block, leaving at 275 meters per second. So this is M2, that's M1. The block was at rest, so the initial velocity of the block was 0. How fast is the block moving when the bullet leaves? Okay, let's write out our givens. The M1 we've already found is 0.035 kilograms. M2 is 2.5 kilograms. V1 is, let's see, it's 475 meters per second. And V2 is 0. I like that because things are going to go away. Now what about after the collision? V1 prime is, I don't know. I want to find that. V2 prime. Oh no, I'm looking for V2 prime. I know V1 prime is what? The mass of the bullet. The bullet is moving at 275. That's an equal sign. Alright, now let's write out our conservation of momentum law. M1 V1, read it straight down. M1 V1 plus M2 V2 equals, I'm going to go ahead and do it this way, M1 V1 prime, now the prime remember means after collision, plus M2 V2 prime. I could have switched these, but I just like keeping them in order. Now let's mark out what is 0. I know V2 is 0, so that whole term becomes 0. Makes me happy to mark things out. Now I'm solving V2 prime. I have V2 prime multiplied by M2, so that's kind of stuck pretty close to it. But I'm adding M1 V1 prime. So I want to get rid of M1 V1 prime, and since I'm adding it, that means I subtract M1 V1 prime from both sides. So I add straight down. This is M1 V1 minus M1 V1 prime is equal to M2 V2 prime. I'm still looking for V2. So circle it. I'm multiplying by m2 to get rid of m2. I divide by m2. So I'm going to divide this whole thing by m2. So v2 prime is equal to m1 v1 minus m1 v1 prime, there's my prime, divided by m2. Now I'm going to plug your numbers in. m1 is 0.035 times v1, which is 475, minus m1, which is 0.035, times v1 prime. Now v1 prime here is 275. Divide this by the m2. m2 is 2.5. Now go on and show me these algebra steps. 0.035 times 475 is 16.625. We're going to subtract 0.035 times 275, which is 9.625. And then we're going to keep dividing through by 2.5. We haven't done anything with that yet. 16.625 minus 9.625 is 7. Okay. Divided by 2.5. And I get a final velocity of 2.8 meters per second. Does this make sense? I have a bullet moving at 475. It goes through a block and leaves at 275. So the bullet loses momentum. The block initially has 0 momentum, but it gains momentum, but its final speed is only 2.8. Does that make sense that 2.8 is much smaller than 275 or 475? Well, yes, because the mass of the block is so much larger than the mass of the bullet. Now, let's see. I have a 5.5 kilogram block, so this is M1, traveling east at 6 meters per second. Hits head-on with a 1 kilogram block moving west at 12 meters per second. After collision, the 0.5 kilogram block moves west at 14 meters per second. Find the velocity of the second ball. All right, let's write our conservation of momentum law. Well, first of all, let's write down what all we know. Let's see, M1 is 0.5 kilograms. M2 is 1 kilogram. The initial speed of the first ball is 6 meters per second, and it's positive because it's going east. The initial speed of the second ball is negative 12. Why is it negative? Because it's going left, or it's going west. After collision, the final velocity of the first ball, so we're going to have a prime there, is negative 14 meters per second. And it's negative because it's going west. Now we need to find V2 prime. Let's read off our conservation of energy law. M1V1 plus M2V2 equals M1V1 prime plus M2V2 prime. Okay, let's see. Let's go on and solve this for V2 prime. We've got V2 prime here, so I'm going to subtract off M1V1 prime from both sides. So I have M1V1 minus M1V1 prime plus M2V2 is equal to M2V2 prime. Now I'm still looking for V2 prime. So I'm going to divide both sides through by M2. And I have to divide the entire side through by M2, not just the part I want. So I'm left with V2 prime is equal to M1 V1 minus M1 V1 prime plus M2 V2 divided by M2. Now I know this is a lot of subscripts. Let's go on and plug in. M1 is 0.5. V1 is 6 minus M1 is 0.5. V1 prime is negative 14. So we're going to go and stick that negative sign in there. Plus M2. M2 is 1 times V2 is negative 12 divided by M2, which is 1. Cool. So let's simplify this. 5.5 times 6 is 3. Let's see, this is going to be plus because I got a negative times the negative. 0.5 times 14 is 7. And negative 12 times 1 is negative 12. So 3 plus 7 is 10 minus 2 minus 12, or negative 2 meters per second. And what that tells me is my final ball will actually wind up going not right, but left at 2 meters per second.